Perfect. Thank you so much, and welcome everybody to this webinar. We will start by talking about AI and machine learning based document processing using RPA. This is part of our series of all the webinars that we've been doing about AI and machine learning for different aspects in the robotic process automation. And today we'll specifically talk about document processing. That seems to be a larger topic nowadays. With me, I have Vachan. Vachan Muralidhar is the lead engineer, machine learning engineer with us here at Accelirate, and he's accompanied by Ramy. Ramy is also part of our machine learning team, and I am Ashish Nangla. I'm the CTO at Accelirate. We'll talk about using machine learning and AI for document processing today. The way we look at the entire document processing and all the other aspects of business processes is essentially when we look at automation, we look at what are the various components of a particular business process that needs to be automated. And I think in some theory, what we look at is different parts and different ways we handle different components of a business process. What we see that differ in some business processes and some organizations is generally the proportion of these. Some are document heavy, some are business rules heavy, some are data heavy, and there are a lot where human judgment is required and there is user action that is required. So those are again handled differently, but there is some of this in pretty much all business processes that we see around, right? All complex business processes, and there are solutions. There are solutions to pretty much all of these nowadays. There is also there is RPA that basically takes care of user actions or human actions that are involved. There are chatbots that do some communication today. There are business rules engine. There's decisioning, there is of course documents, right? So today we'll be talking about documents, and a good solution to tackle document automation is using intelligent document processing, or IDP. That's the industry term that is used today. We'll talk about what it does, what it does not, but essentially it's a broader topic. Intelligent document processing is a broader topic than just OCR or just digitization. So we'll talk about that. Documents. Everybody sees different documents that come in today. Business processes are typically document driven, where people see emails coming in which have attachments, and there are a lot of documents that come in. We still tackle documents that are coming through postal USPS, postal mail, and there is also fax that is still alive in some environments. But generally, things are still dependent on documents being passed on from one organization to the other, one department to the other, in some shape or form, and that's how business has been interacting. We see there is a lot more emphasis happening on APIs and electronic data exchange and some of those aspects, but still the industry is not, or overall businesses have not adapted to that well over the years. There's some businesses that do completely automations in some of those areas, like banks. If you see their clearances and transfers and some of that stuff is completely electronic. And there are some, as I said, we come across companies that are still using postal mail for sending out stuff. So there's all sorts of documents still there to be able to process, right? We define documents, or generally industry defines these documents in three types. There is structured documents, there is semi-structured documents in between, and there is unstructured document. The difference really being structured is something that has a proper form, which is essentially having boxes. Typically, if you see boxes drawn around certain areas where people fill in information, there are templates, and these are templates generally published by an industry body, or generally by an organization themselves, or our public or government bodies, right? So if you see tax forms, and here the example is an accord form from insurance industry, those are structured templates and structured forms or structured documents. Then there are semi-structured, like an invoice, which has a certain set of parameters. What fields they are, and their general way people generally keep this information. There are totals, there are subtotals, there is a number to an invoice. Generally, there are dates and those kind of things that are defined. Unstructured is something that generally does not have any template. It's completely based on on text, which is basically things that we usually get is letters and simple notes by some people that are typing in terms of say adjuster notes for claims, where there is just people typing in what they saw or what they have, inspection reports. uh, in this example, we have some compliance and claim letters as well, or customer interaction emails, or the body of the email, I would say. So those are all considered unstructured. Now, one is because you don't know what the document is, and you don't know, the data is not there in a specific format. You can't just look at it and say, okay, here is how. You have to read through it and try to understand. Some documents are very forgiving because they follow a certain rules in terms of how people write those, which is nice. Like emails, there's text, there is signature at the bottom, and some of that common norms that you see. But letters we see where people type in dates, where you say, hey, I want, like for example, when they're writing for, a loan, they would say give a date, or they would say number of days from today, right? So again, you need to do some understanding on top of that. So that's the kind of difference between structured, semi-structured, and unstructured overall. And the reason why we define these separately is because it also shows the difficulty or ease of extraction. Like structured is fairly simple to extract. You can understand what the template is. There are tools in the market that let you extract data out of these very easily, or fairly easily. Semi-structured, there are a lot of products that are out there that do this, like specifically invoices and receipts and pay stubs. These are typical problems that people have solved. And then there is unstructured, which needs a lot more a lot more work to be able to extract. Typically, there is a machine learning model that runs behind it. So hence our overall topic today is that uses AI and machine learning to solve actually all three. Um, Essentially, what you're thinking is when you're looking at documents and when you're looking at intelligent document processing, it essentially means taking documents and images that come in and making it machine readable information that can actually be processed by an RPA or an application. So it doesn't have to be just RPA or just an application. I believe we should be able to do both. So that's the overall concept of intelligent document processing. Intelligent document processing, why do we need that? Of course, we need it so that we can cover the parts where today people are physically opening these documents, reading them, typing them out. We are trying to see if intelligent document processing can actually improve the automatability of a business process, right? In this case, we're talking about how much coverage automation can have on a business process. And IDP is expected to improve that automatability, because now you don't need humans all the time to be able to read those documents and type it in. That is something that the bot can do by itself. So another typical conversations we have is around why can I not just use an OCR and do this, right? So OCR we call that digitization of documents, which is good if you were just doing taking images and documents and converting them into text. Some OCRs also support structured forms, but as soon as you enter the territory of unstructured and semi-structured and things, just OCR is not enough. You have to be able to define what the document is, define the data out of it, so that you can use it for actual use in a business process or an automation. right? So if you give it a document, you need to actually get, in this case, if you see on the right hand side, you actually need the loan account number out of that document, and not just the text, right? So we need to know that, hey, this is a hardship notice letter, and this is the loan account number out of that, so that a process can actually, or a automation can actually process it. So that's typically what things are. In terms of applications, I would say, Ramy, if you can talk a little bit more about what typical applications we see in IDP.
All right. Yes. Great. Yeah. So first, I just want to say, give praise and thanks to Ashish, because he's the one orchestrating all of our document processing work and our text extractor. This talk is not about text extractor. That's actually coming in 2 weeks. Now we're kind of just educating you on what the field of document processing consists of and how it works. But I want to say, give thanks to Ashish. I'm very grateful to have him as a mentor, because he's orchestrating everything and designing everything, and he's very smart, very intelligent. All right, so getting into the document processing and the typical applications. So there are actually a lot of different things that fall into what you would think of as document processing, and we've already worked on several different applications already. All over the place, we have kind of different applications running. So we have document classification. So this is one application where, let's say you have like a 10-page document, and you want to know, and you're looking at a certain page, and you want to know which page of the document is this. So this is a standardized document. Let's say it's some government form, maybe a government tax form of some sort, and like, what page are you looking at? Is it page 4, where it has all the information of the person filling it out? Is it page 5, where it has maybe some address and health information or something like that? So it's important sometimes to know which document you're looking at in the first place, so that you can know what it is, and that can help standardize processes down the line. So that's document classification. Information extraction is when you have a document, when you've digitized it already, you want to extract that information, so that you can have it in a format that you can work with. You want to collect all your addresses. You want to collect all your names. You want to collect all the lawyers on the page, so that you know their names and you have all of the information. So all of this is done using techniques like entity extraction, regex, regular expressions. There are many different techniques that you can use to extract information from a page. Yeah. So document validation. So what document validation means is that, well, it's exactly actually what it validation means. It means that you want to make sure if the document you're looking at has all of the content that it's supposed to have, or if you're looking at a whole series of documents together in like a several page document, you want to make sure that all the documents are there together. All of them are included, right? So, okay, so that's validation. We want to validate, because we can't necessarily go on with our workflow if things are not what we expect them to be. So that's validation. So moving on. So template-based processing, what is this? Okay, so template-based processing is that basically in certain documents you may have certain structures. Maybe they're lists, for example, or maybe they're tables, which is one of the major primary structures that we are interested in and that we work with right now. So we want to know what tables are there, what tables are there in the page, and we want to identify the tables. Yeah, and ultimately we want to work with the tables and the information in the tables. So it's identifying tables, and we're working on that right now. Yeah, the method is, we're not going to go into the method right now. Okay, that is actually going to come in 2 weeks' time when we do the text extractor presentation. So document summarization. Okay, so document summarization. Many different times, you may be looking at a document and you want to summarize it. You want to get the topic of this document. There are different techniques for this. You can actually use any basic machine learning model or any advanced machine learning model to read the input of the document and all of the digitized words onto it, and then output what of the, say, 4 or 5 classes does this document fall into. You can do that. You can also do something like LDA, or topic modeling, and those are some kind of probabilistic methods of putting documents into buckets. But that's actually more like classifying them into topics. But summarization can also be if it's a long document with a lot of different words and many sentences, then summarization can actually bring it down to 1 sentence or 2 sentences and try to put all of the information of the page into one summary. So that's something that NLP can do. Yeah, it's all based on machine learning as well. Okay, so the final one here, question answering. So what does question answering do? That's basically if you want to build some sort of system, some sort of chatbot, or some sort of user interface where the user can ask questions and the machine learning system can respond to the user, tell them what the answer to the question is. You may also want to ask a question, say, about a particular document. So you may have like a big Wikipedia article in front of you, which is a document, of course, and you want to ask the Wikipedia article a question like, when did this event occur? And then the question answering machine will look through the document and it will try to return the answer to your question, which is, when did this occur? Okay, next, please. So document processing is much more than just OCR. So OCR is just kind of looking at trying to find the words on the page and trying to digitize those words. So instead of being kind of image marks, we get them into kind of text format. But document processing is a wide range of applications. We have all of these scripts, functions, modules, applications that are trying to do many different things, because we end up needing to do many different things when we're looking at documents. Rotation, skewing, finding the edges, different things like that. So you have to source the documents or intaking the documents. This is when you actually read the documents. What format does it come in? They can be paper, they can be already in some sort of software format, maybe a PDF, maybe a Word document. Then you convert it. So maybe if it's in paper, then you would convert it to a PDF, which is usually a format we work with.
Correct. And there are documents there are, sorry, can you mute me?
Yes.
Okay. Yeah. I mean, there are documents that come in various formats. Like there are Excel sheets that come in all the time. There are PDFs, different types of PDFs. There are stuff that is generally when you received as scanned PDFs. These need to be converted. These need to be prepared. There are documents that come in that are rotated, that are skewed. And we have seen documents that are even worse quality than practically possible for us to reproduce how bad things can be. But apparently people scan and print and scan documents all the time. We need to make sure that is ready for that. You need a good digitization solution like an OCR. Of course, then after digitization, you need to be able to classify about what the document is, and looking at every page and say, okay, whether that is what you had expected or not. And then you do extraction of information based on what you classified. So if you said, oh, this is a hardship notice letter, as we said, or this is an email requesting for a support ticket to be created. So you will be able to extract the information. And once the information is extracted, then you would take over as in a bot to be able to do that. So going by the next example, this is what pretty much what we do is the robot generally submits documents to an IDP engine for processing. An IDP engine would do all the pieces of work that you saw earlier in terms of being able to extract and classify and things. Once that is information is given, most of the IDP solutions also give you a confidence score in terms of how confident it was in terms of the data that it got extracted. Again, because of the different quality of documents. Next thing we see is that we generally write a bot to take that document or continue with the bot where it'll take the document data, look for the quality, look for all the adherence to business processes and rules. So if certain, like for example, if you were processing a loan, you want to know all the origination documents are there as per all the requirements before it can be processed further, or it can be queued for somebody, for an underwriter to be taken up. You basically, that if there is any human involvement because the documents were not really good, the data is not there, and you want a human to look in, you would actually assign it to a person for an actual human review. If not, then if everything is available, if the data is correct, and if the data is the system is confident about the data, then it would process that whole thing completely end to end. So that the first part is simply going, if everything is fine, you would see a straight through processing from bot to IDP to bot to bot. Or if there is a need, if it's not, then you would see a bot to a human and then back to the bot. So there'll be an exchange there. So these are typically how IDP solutions are designed, or IDP business processes are automated, that are document heavy or document centric, and essentially what you're trying to do is have human review as less as possible, and eventually take away that work from humans to be able to check each field in each document. Now you only come in and validate something that the bot could not understand or bot could not extract. Okay. Uh, Next, we wanted to talk about a specific use case. Uh, so we can ask Vachan, if you can talk about this use case specifically in terms of processing using natural language processing.
Sure. Thanks, Ashish. That was good. So this is an example for how we process the documents on insurance claims. These are insurance claims documents. So the requirement was they were getting the insurance claim documents on a postal services. So it's a physical paper. So the way we designed that particular architecture was the objective was to extract some of the information from the claim documents they were getting from the customers. So the way we structured that particular project was first we converted that particular incoming documents through the postal services through OCR. So we took OCR of those particular documents. So when you consider the insurance claim letters, so these are actually kind of a bundles. So it will be having a lot of documents, supporting documents, claim letters, medical letters, supporting documents, and all those things. On average, a bundle will be having like 60 to 70 documents. So the important requirement from the business was they need to identify a claim letter out of all these pages. And once they identify the claim letter, they need some information in order to process that particular claim. So this was the objective. The way we designed was we OCR those incoming documents coming from the mail rooms. Then we utilize all the pre-processing required for the machine learning models to classify which page is a claim letter. So once the model classifies which page is a claim letter, then we use a separate entity recognition models to recognize what are the entities that require that we need to extract from the documents. So the entities where what is the policy number, what is the name of the insurer, like when was the incident occurred, and all those things. So all these documents are more related to unstructured documents because it doesn't have any structure. Each and every customer or attorney writes in their own way. So there is no structure for these documents. So these are mostly unstructured documents. So once we extract those particular information from the claim letters, then we integrate the models with the internal systems. So it will get populated to the internal databases and reporting and all. So this is an end-to-end example of how we utilize the machine learning models in the application to process unstructured data. Yeah, that's all.
Perfect. Thank you, Vachan. So that's pretty much in terms of the use cases. I think we'll wait for a few questions if there are any. Megan, are there any questions?
Yep, there's a couple. The first one is, how many documents do we need to train for unstructured processing?
Perfect. So in terms of unstructured documents, I think the part is where you can take a couple of documents to start with, but it really depends on what the use case is and how much variation is there in the documents and what the quality of the documents are. We have done automation with a couple of documents down to a couple of hundreds of documents, and even in some cases where things got really complicated, we needed a couple of thousand documents as well for samples and training. It depends on how much there is also depends on how much there is human interpretation on those documents. And we saw use cases where documents were there was something written on the document, but the user was actually entering something else because they were deriving meaning out of something else that they were presented as well, or some things that were not understood by document itself. So those were harder to do. While there were documents that were simply one-pager documents that had certain good characteristics of features to be extracted, so which did not need much training. Yep.
All right. Next one. How much data and training is required for data extraction problems in unstructured documents?
Sorry, I didn't get that question. How much?
How much data and training is required for document extraction problems?
So structured, few templates, as I said, where unstructured, semi-structured, a couple of more, just based on the type of documents and the type of business. If they fall under the typical categories of invoices and receipts and pay stubs, then there is less work because there's already a lot of work that has happened on that. But if there is new work, then those are pretty much treated as unstructured, and unstructured is what I said, from a couple of documents to a couple of hundred documents based on the use case and quality.
Okay, next one is, can we integrate data extraction models into our internal systems and applications?
Definitely you can. So the two ways you can do that is, of course, use RPA. Something like an RPA bot can definitely help you do that, because again, there's some mechanics to it where you are taking the documents, how you are feeding the documents. But typically we have seen people also using simple APIs to do that. Most IDP solutions provide you with an API where you submit a document and then you go back and after a couple of seconds, you go back and retrieve the data that they have processed, and then work on it in the application. Like, for example, you can take that data and put it in a database for the users to see. So those are the typical ways you can integrate.
Okay.
Yep.
There's one more.
Okay.
It says, do the ML models improve performance on data extraction over time?
They can definitely, if your organization allows models to be updated more frequently, then you could. So every time you're entering the data, we could actually create a feedback loop and make sure that the documents or the extraction gets better and better over time. But there are some organizations that do not allow that. Essentially because of compliance requirements and other requirements that they have, where models need to go through compliance reviews and stuff. But otherwise, yeah, definitely, and that's the good part about such kind of projects, that where you see lower accuracy probably at the start and lower outcome, but then that improves over a period of time as things go. Okay.
Okay, yeah, that was the last one.
Okay, perfect. Thank you so much, everyone. We'll see you soon on our next webinar. Thank you again.
Thank you, everyone.